Hi, and welcome back to my OpenTK 2D game engine / framework series. This is part 2, and in this episode we are going to do two things actually. We're going to properly implement the windowing, so when we pass in the window size, this actually is what gets applied. It'll apply the title, and then what we'll also do is get a triangle to render. Now I know that's not the most exciting thing, but unfortunately that's kind of where things get started. And ultimately the goal of this is to try to get something on the screen very quickly. So the first thing we will do is actually implement the window sizing. And as a side note, while I'm getting there ready, I want to apologize. I noticed my last video, the text was rather small. It was probably a little hard to read. Depending on the feedback, I will go back and recreate it and re-upload this, and with it zoomed in a little more, hopefully the size is good, but I guess we'll see. So what we'll want to do is actually set these values. So this is actually set in the native window settings. So if we take this, we can do let's say size equals new vector 2i, and we'll go ahead and import the mathematics, and that will be the initial window width, initial window height. I just noticed I have a error there. Initial window height. There, that's better. Okay. And then to set the title, it is just simply native window settings.title and window title. Alright, so if we did everything correctly, let's make it small so we know it worked. Let's fire this up. Yep, and that is pretty small. And we'll set it back to our 800 by 600. All right. So when supplying the graphics card with the data it needs, it is working in a different coordinate system than what you might be used to if you have worked with games before, or even with just a window. So take this for example. When I make this small, when you would treat this top left of paint here as 0, x and y, and anything down here, the x increases as I go right, and the y increases as I go down. And then that's how these coordinate system works. In the context of this, the graph, there's different types of coordinates, and we'll get to them. There's these coordinates, and there's texture coordinates as well, which also work differently, but we'll focus on this one. So these, I apologize, I do not know the name of them off the top of my head, but they work a little bit differently. Okay, so think of it like this. It kind of works a little bit closer to how it actually makes a little more sense to humans in a way, because it's kind of like a canvas that's being painted. So let's say this is our target, and then the graphics card is going to be working with from a range which is called normalized coordinates, which is a value anywhere from -1 to +1. So with the way that coordinates worked earlier, the way we're discussing, this would be increasing the value, and this would be increasing the value. Well, it's a little bit different. So this still remains 0, 0, nothing changes. So remember, we're between 1 and 0, so this would be 0, 0. But then up here would become 1, 1. See how the value increases as you go up to the right. So it kind of works more like, I don't know, a graph. Maybe that's not a good way of putting it, but that's kind of what I'm getting at. So over here, this becomes -1 and 1 because it's still facing upward, but to the left it's negative. Down here, it becomes -1, -1. And then down here, it becomes 1 and -1. Okay, And that's because the y-axis is going downwards. So that's why y is -1 and x is 1. So if we go back into our code, we can supply these coordinates. We're going to create a private read-only float array. We're going to call it vertices. And we'll initialize these. So the bottom left, so if I go back to paint here. So the bottom left, we want to put it right about here. So let's go ahead and draw how we want this to look. I want this to look roughly something. Paint is not my expertise here. We want something kind of like this. So we want it in between. So -0.5 and -0.5 would put us at this point right here. So let's go ahead and add that. 0.5, and these have to be floats. -0.5f. And then we have to supply it a third one. You technically don't have to do this, and we'll get into it later. But just for now, we'll just set this to 0. And we'll just provide that. So the next set that we need to provide it is the bottom right vertex. So the bottom right vertex would be down here. So this would be a positive. So this goes to the right 1 on the x-axis. So we're going to do a 0.5, and then halfway down the negative would be give us -0.5. So we'll update that. We'll just we can just go ahead and comment this here to let us know, bottom left, and then we want 0.5f, -0.5f, and then 0.0f for the z-axis, and that is our bottom right. And then we need to supply the top vertex. So that would stay on the x-axis, that remains 0. But then we increase it, so we go up, and that would put us at 0.5 in the for the y, and then of course 0 for z. So we'll add that. Spacing matters. And I'm just kidding, it does not matter. It just looks a lot cleaner. And that becomes the top vertex. Okay, so that looks good. I have to say it equals that. So then what we're going to do next is we need to have what's called a vertex buffer object and a vertex array object. Before I get too carried away, I would like to explain on a very high level how OpenGL works. We're using OpenTK, but OpenTK is simply a wrapper for working with OpenGL and C#. You need to know how OpenGL works in order to leverage OpenTK properly. Even if you are not a C++ developer, I would still check out the website learnopengl.com. I will leave a link in the description. Reading through those tutorials will give you a good idea on how OpenGL works, and it uses C++. And if we're being honest with ourselves, a true top-notch game engine should probably be done in C++, but we're doing this in C# on purpose. Everything that you read up on OpenGL is applicable to OpenTK with just some slight variations. Once you're comfortable with OpenGL, you'll be able to know exactly what you need to do in OpenTK, and it'll be really no different no matter which language that you're reading it in. You also can use OpenGL by invoking the what's called GLFW directly in C#. I think you're marshalling, and you can get the function pointers and call them. I'll save that for another series. That's actually pretty fun to do because I started off by learning GLFW, so that's actually kind of what I'm more comfortable with. I'm somewhat newer to OpenTK. So OpenTK or OpenGL. So I'm going to take this from their website here on Learn OpenGL, and let's take a look here. OpenGL is mainly considered an API.
It provides us with a large set of functions that we can use to manipulate graphics and images. However, OpenGL by itself is not an API, but merely a specification. That's important right there. So you could think of OpenGL as a specification more than an actual API. It's a specification that all graphics card manufacturers just kind of agree that, okay, if you do this, this is what it's going to render. So it might be different on each graphic card, but you're going to end up with roughly something the same. And you could think of it too as, you know, if you're using OpenGL, it works on multiple platforms. Well, let's say if you're writing a real game engine here, let's say we're really trying to write one, you would probably have a way to work with OpenTK using OpenGL, or a way to work with DirectX if you were on Windows. This way you are leveraging the best for that operating system too. So it's really up to you. I'm personally do not have the cognitive endowment to understand anything beyond OpenGL. That's about as far as my brain can handle. I don't think I could realistically learn Direct 3D and know this together, but maybe someday I'll take a stab at it. So there are two things that we need to build here. We need to build what's called a vertex buffer object and a vertex array object. So a vertex buffer object, or VBO, is an OpenGL feature that provides us methods for uploading vertex data, so stuff like positions, color, etc. You can make it whatever type of data type you want, but it's just a way for us to provide some buffer onto the graphics card, because we are working in I think it's core profile mode. We're not using immediate mode, and that's because immediate mode is becoming deprecated. It's kind of the old way of working with OpenGL, but there's no reason to learn it. And then what we also need to create is a vertex array object, or a VAO. And that stores all the state that's needed to supply with vertex data. So you could think of it as a VAO is a container with vertex buffer objects. It's just a way to somewhat group them. I'll admit that I'm not 100% sure on the value of their use. That might be something that I can speak to a little bit better as we progress, but with that out of the way, let's go ahead and get started, and let's get a triangle on the screen. Okay, so we're gonna create a private, if I can spell, int vertex buffer object, and a private int vertex array object. And then down here in our onload, we will generate this, the first buffer. So let's go ahead and generate the vertex buffer object. So vertex buffer object equals gl dot gen buffer. And then remember, it's a state machine, so we're supplying it with what it needs. So we have to change its current state. We need to bind this buffer. So we have to tell it that we're going to bind buffer targets dot array buffer, and then we'll use the vertex buffer object, and then we have to give it the actual data. So the data, we will do gl dot buffer data, and we have to tell it we're on the buffer target array buffer. Target dot array buffer, and then we need to tell it the size. Now this size, I believe we have to supply it. This is where we can actually make use of the size of operator in C#. It's not very often that I've come up with a use case for that, and this is actually one of them. So first thing, you tell it that it is the vertices. So we need to take our vertices, and we can get the length of it, and that will give us the number of vertices we have. And then it needs to be times the size of float. So this way it knows how many bytes it needs to allocate. And then we supply it with the actual data, which in this case is vertices. Vertices. And then we have to provide it with a hint. Now, this is just going to be static, but this just kind of helps the graphics card know how should I render this. Is this something that's going to change frequently? Then I probably want to have it do a dynamic draw. Or if I'm going to be streaming it in, then I want to do a stream draw. Or this is hardly ever going to change. If it's not going to change if ever, it's just static draw. So we'll tell it static draw. And then now we need to generate the buffer array. So we do that just like we did with the vertex array object, except it's slightly different here. So vertex array object, we're going to say equals gl.genVertex array. And once we've done that, we need to bind it, bind vertex array. Notice that we're calling instead of bind buffer, it's bind vertex array. It has its own method. And then we have to supply it with the vertex object. And then we need to enable a vertex attribute pointer. I'm going to just kind of give you the code for this right now, and it's going to make a lot more sense when we get into shaders, because actually I'm going to save this next part. Let's just go ahead and do the syntax. Just trust me, this is going to work. I'll explain it a lot more in depth in the next video, and it's going to make a lot more sense. But first we do gl.vertex attrib pointer, then its starting index is at 0, 3, and then we're telling it the type, so it'll be vertex attrib pointer type dot float, because that's the type of data we're working with. Then we need to tell if these datas need to be normalized. Now, I always thought this parameter is a little confusing, because when I first read this, it says bool normalized. So that's meaning, are we saying the data is normalized or not? This is actually saying if it needs to normalize the data for us. These values are between -1 and +1, so it's already normalized, so we're going to pass in false. Then we have to give it the stride. We have to tell it how is it supposed to read this. When it gets this object and it's being passed in, what's the stride of it, right? So we know that we have 3. We have 3 vertices, 3 points, and those 3 points are made up of 3 floats. So we have 3, 2, 3, and then that's going to be the size of float. So just like we did up here for the length of it, we need to say because there's 3 different there's 3 vertices, I suppose you could think of it, 3 complete vertices, times the size of float. And then this would be the offset, which is just 0 for this. And then we need to enable vertex attrib array 0. And that's just pointing to this one here. Like I said, this will make a little bit more sense as we get into the next video and we start getting into shaders. So I think we can leave the update frame alone. We don't need to do anything there. It looks like it's not using vertex buffer object. I think I made a mistake. Yes, I did. I apologize. This one here, this should be vertex buffer object, not vertex array object. I apologize. Make sure I didn't. And then we need to say the array buffer is the vertex buffer object. And then this is the vertex array object. All right, I apologize. All right, so now in our render frame function, we need to bind the vertex array. So we can call this after we call GL clear. So we do gl.bind vertex array, and that would be our vertex array object. And we do gl.draw arrays. We're going to use the primitive type.triangles. I think this is yet to be determined, but once we start getting into stuff like sprite batches and providing this to make this kind of seem more like an actual game engine, we'll probably just be drawing quads, but we're going to go with triangles for now. You can still technically use triangles to draw quads, quote unquote, but we'll continue. So the first one is we're starting at 0, and there's 3. Just like here, we're starting at 0, and there's 3 of these. So I think that might be all we need to do, because this draw is what actually tells it to draw, because this is drawing to the back buffer. So you could think of that as what's currently on the screen is what's currently on the screen. What's going through this render is what's going to be rendered next. And normally you would have to call swap buffers, but if you remember from earlier on, we're calling swap buffers after we call render on here, so we don't need to. We might change that, but for now we're going to leave it. So if we did everything right, this should draw a triangle, and let's see. And there we go. We have a black triangle. And the reason this is black is because we didn't provide it any information about color. On yours, it might be different, and on yours, you might not actually see anything. So if you're made it this far and you do not see a triangle on the screen, it is possible that your graphics card is not providing a default shader. And in this next video, we're going to be writing a shader, and we're going to change the color of this. So if, like I said, if you are not seeing anything at this point, don't panic. You might not be able to see it until you supply it a shader. So I think we're going to call the episode here. I'll wrap this up. Yep, so I think I've already covered the next episode. We'll cover shaders, and then we're going to work on getting textures to load, and then work on cameras, and pretty soon we'll be able to just start writing up code that looks similar to Monogame, except it's our own, that we can love and hold, and we can be proud because we wrote it and we know exactly how it works. If you like this content, please like and subscribe, and we'll see you in the next episode.